All right, we've learned to add vectors together in one dimension. 3 plus 4 might equal 1 or negative 1, depending upon the signs of those vectors. We've learned to add them together in 2 dimensions now. In fact, we've learned to add multiple vectors in 2 dimensions. Maybe we have 3 or 4 or 5 vectors. We can add those together now by getting a right-angled triangle vector diagram and then doing the Pythagorean theorem and the inverse tan function. What if the vectors, or one of the vectors that I'm trying to add, has what I call a funny angle? A funny angle is something other than 90 degrees. So it's not this or this, but rather, what if one of the vectors that I want to add to another vector looks like this? I've got a magnitude of 10 meters at an angle of, let's say, 30 degrees. That would be 30 degrees what of what? Where's it measured from? Where's the angle measured from? From the north, south, east, or west? It's measured from the east, right? Okay, this dotted line here is the east. It's measured from the east, so this would be north of east. Good. What if I want to add that vector to another vector? Well, this is tougher. Here's what I want you to do first. Okay, I want you to remember these 5 words, and then we'll develop the strategy to solve the problem after you remember these these 5 words. Okay, repeat after me. That wasn't very good. Seriously. Can't repeat I? Okay, let's try this again. I know it's Monday morning, but repeat after me. That's better. Well, only one person did it. Only one person said that's better. Okay, let's start again. I don't like funny angles. If you got a funny angle of 30 degrees, I don't like funny angles. I don't like them. So the goal here is ultimately to get a right angle triangle, but in order to get the right angle triangle, I've got to get rid of my funny angle. I got to turn that 30-degree angle, 10 meters and 30 degrees, into something else that's more recognizable, that's easier for me to deal with. It's not a funny angle. How are we going to do this? Well, let's just real quickly review the XY plane, and then we'll deal with that funny angle here. So this is my XY plane. As you guys know, everything horizontal is X, everything vertical is Y. Okay, we go to these 3 quick examples here. We know how to do this, right? This is nothing for us. How much of this one is X? How much is Y? 10 and 0. How much of this one's X? 0. How much is Y? 200. How much of this one's X? Negative 50. How much of this one's Y? 0. 0 and negative 35, right? No problem. No problem. We got to do the same thing, though, if we have a funny angle. We have to figure out how much is X and how much is Y with the funny angle. How much of these ones are X and Y? This is harder, isn't it? Hey, when I see this question, question number 1, 5 words should come to my mind. I don't like funny angles. Good. Okay, that's the first thing that I want you to recognize. Now, notice we've got a single vector here. We're not trying to add vectors together yet. Okay, what's going to happen tomorrow is that we're going to combine a couple of things. We're going to add vectors together like we did earlier today and on Friday, but we're going to add vectors together that have funny angles involved. Today, we added vectors together. Right now, we're just learning how to resolve funny angles, and then tomorrow, we'll put those 2 concepts together. Okay, so right now, we're not adding, we're just getting rid of the funny angle, turning it into something that's a little bit simpler here. Here's how you do it. Here's how you get rid of the funny angles. And that's exactly what we want to do because we don't like funny angles. I want you to take your pen or pencil and draw a triangle around the angle. You draw a triangle around the angle. So I wouldn't draw it up here. I mean, I could draw a triangle up there, but it doesn't surround the angle, right? The angle needs to be inside the triangle. Let's see. So the green one is not the one we want. It's the blue one we want because that puts the angle inside. We do the same thing over here, right? We wouldn't draw it over here. That would form a triangle, but the angle wouldn't be inside the triangle, so that's not what we want. Rather, we draw it like this so that the angle is inside the triangle. Put your arrows on there. Right? How do we know which way to put the arrows? Well, they're going front to back. Okay, this is my resultant vector drawn front to back. And of course, we're going up and to the right, so we have to draw them. And we're not going to draw it to the left, right? When the resultant vector is going up and right. Now let's label this as X and this is Y. Any ideas? How am I going to find the value of X? How am I going to find the value of Y here? Kelly? It's a pretty special triangle, actually. What am I going to do with this special right angle triangle? Alex? Yeah, sine and cos. Do you guys remember, I mean, tan is opposite over adjacent, right? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Which one's opposite here? X or Y? Y, good. Which one's adjacent? X. Adjacent is touching the angle, but not the longest side, because that's the hypotenuse. So if I want to find X here, I'm going to say cosine 30 degrees is equal to X over 100. X is adjacent over hypotenuse. Cosine 30 is equal to adjacent over hypotenuse. And I'm going to say sine 30 degrees is equal to opposite over hypotenuse, which is Y over 100. Let's solve for the value of X. To do that, I'm going to take the 100 up by multiplying, right? It's divided, take it up by multiplying, becomes 100 times cosine 30, 86.6. And Y is going to be 100 times sine 30, which gives me exactly 50. So look what I've done. Here's what I have now. Instead of 100 meters at 30 degrees north of east, I've got 86.6 meters and 50 meters. So now I got two vectors instead of one, but it's not at a funny angle. And now I could add these two together along with other vectors the same way as I did those other questions earlier today. Okay, what would you rather see in a question when you're adding vectors together? 100 meters at 30 degrees or 86.6 and 50 meters east and north? I don't like funny angles, so I want to get rid of them. And I get rid of them by using cosine and sine. Let's do this last one and then I'm done. This one's going to be X. This one's going to be Y. Which side of the triangle is X? Opposite, adjacent, or hypotenuse? Opposite. Opposite in hypotenuse goes with sine. Sine 30 degrees is equal to X over 20. 20 times sine 30 gives me 10. I use cos for X over on the left one, sine for X on the right one. Cosine 30 degrees is equal to adjacent over hypotenuse. The adjacent side is Y. 20 cosine 30 is, I believe, 17.32, I think. Well, now I don't have to worry about the 30 degrees. Now I've got two vectors. One's 10, one's 17.32, but they're both on an axis. I would like you, for the last 5 minutes of class and for homework tonight, to please work on questions 6 to 13 on your worksheet. 6 to 13 on your worksheet, please.